welcome to another interesting maths class. My name is Manuela Ndiomu, and today I'll be teaching you Trigonometry Part 1 under the theme Mensuration and Geometry. But before we go into this lesson, let's take a look at our lesson objective. By the end of the lesson, you should be able to identify the sine, cosine, and tangent of an acute angle. The word trigonometry is gotten from two Greek words, and they are trigon, which means triangle, and metria, which means measurement. So, trigonometry is a branch of mathematics where we study the relationship between the sides and angles of triangles and their measurements. Because trigonometry was created by Greek mathematicians, Greek letters are often used, such as alpha, theta, beta, and delta. Moving on, let's look at this right angle triangle, ABC, with the angle theta. When looking at a right angle triangle, we identify the three sides of the triangle according to how they are placed in relation to the angle given. Now, looking at our given right angle triangle, where the angle given to us is theta, the side opposite the right angle is known as the hypotenuse. Now, the hypotenuse is the longest side of the triangle. Now, the side opposite the angle given is called the opposite side, and the side next to the angle given is called the adjacent side. Now, let us assume that the angle given to us was on the other side of the triangle. The hypotenuse remains the same because it is always opposite the right angle and it is always the longest side of the triangle. But our opposite and adjacent side will change because they depend on the angle given. So looking at this given triangle, our opposite side will change to BC and our adjacent side will change to AB. Now, note that the definitions of our hypotenuse, opposite side, and adjacent side can only be used when we are working with a right angle triangle. So we always make sure that we are working with a right angle triangle before we apply the definitions of our opposite side, adjacent side, and hypotenuse, or else we will get the wrong answer. In trigonometry, we have three ratios for the sides of the triangles, and they are sine, cosine, and tangent. So when we are given a right angle triangle, we can find the sine, cosine, and tangent of any of the given angles. Let's go on as we look at sine. Now consider this right angle triangle XYZ, where we have our opposite side, hypotenuse, and adjacent side. In a right angle triangle, the sine of the angle is the length of the opposite side divided by the length of the hypotenuse. So to find the sine of the angle theta in the right angle triangle XYZ, the mathematical expression is sine theta is equal to opposite side over hypotenuse. Let's take a look at an example. Example 1. The diagram below shows a right angle triangle with the sides of length 3, 4, and 5 units. The angle given is alpha. Determine the value of sine alpha. Now, step 1. Identify the three sides of the right angle triangle given. Now, if we look back at our triangle, we will see that the hypotenuse is 5. The opposite side is 3 because it is opposite the angle alpha. And the adjacent side is 4 because it is beside the angle alpha. Step 2. We write down the definition of sine alpha and substitute the correct sides. Our mathematical expression for sine is opposite side divided by hypotenuse. So substituting our values, we will have sine alpha is equal to 3 over 5. In a right angle triangle, the cosine of an angle is the length of the adjacent side divided by the length of the hypotenuse. So to find the cosine of the angle theta in the right angle triangle XYZ, the mathematical expression is cos theta is equal to adjacent side over hypotenuse. Now going back to the example given for sine, let's look for the value of cos alpha. So step 1, we identify the three sides of the right angle triangle given. We have our hypotenuse to be 5, our opposite side to be 3, and our adjacent side to be 4. Step 2, we write down the definition of cos alpha and substitute the correct sides. Cos alpha is equal to adjacent side over hypotenuse. So substituting our values, we will have cos alpha is equal to 4 over 5. And finally, we will look at tangents. Still looking at our right angle triangle XYZ, the tangent of an angle is the length of the opposite side divided by the length of the adjacent side. So to find the tangent of the angle theta in the right angle triangle XYZ, our mathematical expression is tan theta is equal to opposite side over adjacent side. Still on the same example, we will find the value of tan alpha. So step 1, we identify the 3 sides of the right angle triangle given, where we had our hypotenuse to be 5, our opposite side to be 3, and our adjacent side to be 4. So we write down the definition of tan alpha and substitute the correct sides. Tan alpha is equal to opposite side over adjacent side. Now we write down the definition of tan alpha and substitute the correct sides. Tan alpha is equal to opposite side over adjacent side. So substituting our value, tan alpha will be equal to 3 over 4. Having looked at the 3 trigonometry ratios, we have come to the end of this class. But before we go, let's take a look at a quick summary of what we have learned so far. We learned that trigonometry is a branch of mathematics where we study the relationship between the sides and angles of triangles and their measurements. We also learned that in trigonometry, Greek letters are often used because it was created by Greek mathematicians. We also learned that in a right angle triangle, the 3 sides are identified according to how they are placed in relation to the angle given. And finally, we learned that in trigonometry, we have 3 ratios for the sides of the triangle, and they are given special names. The names given are sine, cosine, and tangent. It's test time. Question 1. Give the ratio for tan theta in the following triangle. Option A, 12 over 15. Option B, 9 over 15. Option C, 3 over 4. Option D, 4 over 5. The answer is option C, 3 over 4. Question 2. The name of the trigonometric ratio adjacent side over hypotenuse is option A, tangent. Option B, cosine. Option C, secant. Option D, sine. The correct answer is option B, cosine. Thank you for your time. I'm sure you can now solve for the 3 trigonometric ratios we have. Till we meet again, bye-bye.